Welcome to separation and purification techniques. So today we're going to talk about the first thing is the difference between your pure substances as well as a mixture. So let's take a look at pure substances. Pure substances, the definition is it has a fixed composition, which means a single substance not mixed with anything. So what do I mean by this? So let's take a look here. Currently we have one beaker here. Inside maybe we have a molecule A. And inside here, there's only molecule A only. So all of them is A. Therefore, this is what we call a pure substance. But you see, a pure substance, not necessarily you only have one element. Maybe, you have another beaker here. Inside, is A combined with B. So whenever you see, a beaker here have A combined with B together, as long as this itself exists by itself, it's called a pure substance. Now we understand what is meaning of pure substance. Let's move on to mixture. So for mixture, what are they? Let me give you an example here. So a mixture will be a substance that look like this. For example, you have a beaker here. Inside maybe you have A, you have B, you have A, you have C. So you have many different substances combined together into a beaker. This is what we call a mixture. So a mixture definition simply means that it's a substance we have no fixed composition and it contains two or more substances. A classic example would be seawater. Because in the seawater, you can see that it contains water and you also contain your salt, which is your NaCl, or maybe it contains some dirt, so on and so forth. Then, for example, your air. Air contains of what? Oxygen, nitrogen gas. These are considered as mixture. How about alloys? Alloys simply means that it's a more than one metals combine them together. This is called an alloys. So there's a difference between your pure substance and a mixture from a composition point of view. But let's take a look a little bit further in terms of its physical properties. So let's go down and let's see. Now, for the physical property wise, very simple. For pure substances, it has a fixed melting and boiling point. What about fixed here? So you can see, when a pure substance melts, it melts at constant temperature and it boils at constant temperature. The temperature is constant. You should remember the reason behind this. This is because, the amount of energy is used to overcome the intermolecular forces of attraction instead of used to increase the temperature. So keep this in mind, the amount of energy used to overcome the intermolecular forces instead of used to overcome or increase the temperature. The same as boiling point as well. So it changes from liquid directly to become gaseous. The energy is absorbed to actually overcome the intermolecular forces. That's why the melting and boiling point are kept constant for your pure compound. But let's take a look further on the mixture. The mixture is not fixed composition. Simply means that inside here you have a beaker. Maybe you contain A, you contain B, you contain C. You got three different substances. Now, if you begin to melt them, there's one problem. For example here, your compound A, maybe it melts at about 80 degrees Celsius. Your compound C maybe melt at 90 degrees Celsius. Your B is 100 degrees Celsious. So you can see there's total of three different boiling points around here. So this is what will happen if you attempt to melt the substance, instead of melting exactly at 80 and kept constant at what you see in fixed composition. When A start to melt, temperature will continue to rise because you still got your compound C, which is 90 degrees Celsius, then followed by a compound B, which is 100 degrees Celsius. That explains the reason why the temperature slowly rise over the period of time, because you need to melt both A, B, and C. Hence, a mixture always melts over a range of temperature. Not only melts, it boils as well. But one more unique characteristic about the mixture is that the boiling point is always going above the boiling point. So what do I mean by this? For example, right now you have a water molecule supposedly to be 100 degrees Celsius. Just imagine if your water is like salt water. Remember, salt is actually a mixture. Instead of boiling at 100 degrees Celsius, maybe you boil at 102 degrees Celsius because the boiling point must be above 100 degrees Celsius, is 102. Then another example will be your melting point. Melting point is a little bit different. It will actually melt below. So what I mean by this, for example, your ice normally melts at 0 degrees Celsius. But if you have a mixture, instead of melting at 0 degrees Celsius, it will melt at maybe let's say -2 or even -5 degrees Celsius. As you can see here, the temperature is actually much lower comparison to 0 degrees Celsius. That's why mixture is melt below the melting point. Now let's take a look further. Now, besides looking at the melting and boiling point direction, of course, we also have other ways to examine whether a compound is pure or not, which is using what we call chromatography. Now, keep in mind, chromatography is a way to identify the compound that is present in the substance. It is not as a means to really separate them in bulk amount, only used to identify. Take for example, I want to examine the secret recipe of KFC. So I just put the KFC into chromatography. I see the spot. Your KFC got this spot, got this spot, got this spot. Therefore, chromatography is good in identifying what is present. But if you want to separate the whole of the KFC content in the whole KFC recipe, it's impossible to be achieved using chromatography, because chromatography is just used to identify and separate what we call trace amount of substances. So keep this in mind, the word is trace amount. Now, if it's a pure substances, you only can see a single spot. Single spot simply means that, you see here, you have a thin layer of chromatography. Inside here, you have a starting spot. Then end up, you only see one spot. So this is what we call the starting point. Then at the end of the day, you only have one spot. So this is what we call a pure substance. But let's take a look at impure substance. Impure substance, you got one problem. You have more than one spot appearing. So what do you mean more than one spot? For example, currently, you have a thin layer chromatography. So starting, then you get 1, 2, or you get actually 2 spots. So not so pure. That's why impure substance normally have 2 or more spots present. So this is what we mean by impure or mixture substances.